In these next two examples, we're going to look at something called Z-alpha notation, which is related to percentiles. So let's look at a picture here. So if I want to look at Z.05, that means that 0.05 is the area to the right of that Z value. So these are Z-scores we're talking about. So that means that this is going to be somewhere over here on the right side of the distribution will be your Z.05. And then 5% of the area, 0.05, is to the right of that value. So that means 95% is to the left. So this is actually the 95th percentile, which is how I knew it was on the right. Only 5% of the area is to the right. If you're in the middle, 50% is to the right. So how are we going to do this? Well, we're going to use inverse norm because it's a percentile. And then the left area is 0.95. And then it's a Z-score, so your mean standard deviation are 0.1. So let's go ahead and compute that in the calculator. So we want to go to second variables, option 3 for inverse norm. Our left area, 0.95, mean 0, standard deviation 1. So those are by default 0 and 1. So if you may not have to change them. Paste, enter 1.645 to 3 decimal places. Let's look at another example, Z.10. So that means 0.10 is the area to the right. So again, that Z.10 is over here on the right side of the distribution. The right area is 0.10. That means the left area is 0.90. So we're going to do our inverse norm again. And you always put in left area for inverse norm. So 0.9 is our left area. Mean and standard deviation, still 0 and 1. So go back to the calculator, second variables, 3 for inverse norm. Left area now 0.9, still 0, 1 for mean standard deviation. And paste and enter. 1.28 to 2 decimal places. And remember, z-score of 0 is in the middle. So positive z-score is to the right, negative to the left. Now notice here that 0.10, if you have the left, right, center menu on your calculator, so if I go back here to the second variables and option 3, if you've got the left, right, center here, you could put in the right area. So I could do right area of 0.1, but then I'd have to come down here and change it to right. And then I can paste it, and I get my same 1.28. However, if you change that, the next time you use it, you have to be sure to change it back to whatever you need. Most of the time you need left area. Sometimes you need center, and that does come in handy when that's the case. I recommend leaving it as left and just always using the left area, and that way you won't forget to change it back. But you can change it if you want to. Let's look at one more example. So here we want negative Z.01. So Z.01 would be over here on the right-hand side, and that is the z-score with 1% or 0.01 to the right. And that means that 99% is to the left. So that means that this area here to the left is 0.99. And then we want negative of Z.01. So whatever this value is down here, we want the negative of it. That'll be on the other side of the distribution. So this is negative of Z.01. So we've got to find the positive one first. So Z.01, let's find that first. That's going to be an inverse norm. And then our left area is 99%, 0.99. Mean and standard deviation, still 0.1. So let's compute that. So second variables. Number 3 is inverse norm. Left area, 0.99. Come down and make sure we mark left. Paste, enter. 2.33 approximately. So then that means that the negative of z.01 is going to be negative 2.33. So these values, these subscripted z-values, those will come into our inferential statistics when we do confidence intervals and hypothesis testing. You'll see this notation. So that's where that comes in. So just wanted you to be familiar with that before we get into the inferential statistics.